All right, what's up, y'all? So, I wanted to do a little talk about some things and clear up some things. So, I noticed that here lately, this has become the time of buzzwords. So, people hear stuff and they automatically think something negative, and stuff be on me. Anyway, they'll automatically think something is negative when it's not always the case. So, I guess basically the main thing when I'm talking about is GMOs. GMOs has almost become like buzzwords like CRT and Black Lives Matter, all that kind of stuff, to where it's become when people say these words, we want the masses to automatically think something negative. And that's what's become of GMO. Now, am I saying that GMO is a good thing? No. So y'all just hear me out. Because basically what this video is kind of clearing the air and telling people to kind of use their brain a little bit more, to think critically a little bit more, and to be a little bit more level headed. I think this society pushes people to be from one extreme to the other, but being at either extreme of any spectrum is actually not a good place to be. You should try to be as close to the middle as you can. It's just like something being alkaline and acidic. If something's way too acidic, it can burn you. If something's way too alkaline, it can burn you. You get what I'm saying? What's the good spot to be? Is neutral, right in the middle of the spectrum. That's where water is. So let's get into it. So I heard some misinformation where I was watching some on YouTube and this guy was saying that, oh, you can tell if something is GMO if you get it and it won't regrow. So his whole thing was like, if he takes the butts of onions or celery, or if he takes a potato or something and tries to grow it, if it won't grow, then it means it must be GMO. And if it grows, then it's not GMO. That dude couldn't be further from the truth to know what he talking about than a man in the moon. That's not how you tell if something is GMO or not. To be very, very honest with you all, the only way that you can tell if something is GMO or not and be 100% for sure is if you did genetic testing on it and you looked at the genes in the genome. That's the only way. And nobody has that kind of equipment at their home. You have to have a very sophisticated scientific lab to have those equipments. The only places that have those equipments are universities and things like National Institute of Health or the CDC or something like that. Very, well, I want to say institutions that have a lot of money, because if you don't know it, scientific research costs a ton of money. It's not like a little bit of money, it's a ton. Like, the only other thing I could think they pour money into, the way they pour money into scientific research, is the military. But military does a lot of research too. Understand that too. Like, they don't just come up with these bombs off the top of their head. It takes a lot of research and scientific things to come up with all that stuff too. That's why so much money goes to ballistics and creating all the military stuff that they create, from the vehicles to the planes to the, not only does it take a lot of resources to make them, it takes a lot of research to make them do what they do. It's the same thing in the science realm. um, so research as a whole, across the board, across any industry, is the most expensive part of most stuff. So people are not going to have the equipment to say 100% whether it's GMO or not. But that being said, and let me break down exactly what GMO actually is, because I think people sometimes really don't even know what it is. So, because I see people getting GMO and hybridization mixed up all the time. GMO and hybridization are not the same thing. For instance, if you have two varieties of, let's say, cucumbers, and a human takes pollen from one cucumber variety and puts it on the female cucumber of another variety, saves those seeds, and grows that cucumber the next year so that they have a new hybridized cucumber, that's not the same as genetically modified. Is pollen genetic material? Yes. Is seeds genetic material? Yes. But that's not genetically modified. Genetically modified usually refers to when they take genes from a certain species and put it on a different species, and it's usually a totally different species. So, what do I mean by that? Oftentimes, they will take, your motorcycle is very loud. Oftentimes, they will take genes from microorganisms, whether it's bacteria, fungi, or something like that. And they will take those genes and in a petri dish, they will insert them into the genetic makeup of some type of plant. Okay, you follow me? So, microorganism, that's something that you can't see with the naked eye. So, that's going to be bacteria, fungi, certain fungi. Not all fungi is microbacteria, but you have, like, for instance, one tiny mold spore particle, that's a microorganism. But usually by the time you see molds, you can see it with your eyes. Um, that's millions of them. You get what I'm saying? That's millions of little molds, spores, cells, whatever you want to call them. That you're seeing. You can't see just one because believe it or not, there's mold on everything. But most mold is not harmful to humans. Just like powdery mildew is not harmful to humans. If you touch it, it's not going to do anything to you. Um, but yeah, so when you take something from one species and put it into another species, and like I said, they usually take stuff from the animal kingdom and put it into a plant species to make it disease resistant or whatever they're trying to make it do. They're trying to make it do something that it naturally just does not do. There are instances to where you can take um, genetic material from one plant and put it in another plant. But like I said, GMO really speaks to when you're doing these things in a lab and you're doing it on a microscopic level. Um, and you're doing it in a very, very artificial level. You're not doing it in a way that it actually can happen in nature. Because, see, the scenario I gave earlier with the cucumbers, that actually can happen with a bee. Plant two varieties of a cucumber right next to each other, a bee will do the same thing. It'll go from flower to flower to flower. It doesn't know that those are different. It just wants pollen. It just wants nectar. It just wants, you feel me? And so those hybridizations, that's not really the same as GMO in that sense. Not in the sense that how these things are taking over now. Um, so can GMO be bad? Yeah, it can be. Especially if you're talking about ingesting different things. That's why GMO corn is an issue because corn is in so many things. And they wonder what happens over time if you're ingesting these genetically modified things. And really, in the corn industry, I mean, I see what farmers are trying to do. It's not necessarily that I agree with it. I think they should change their growing methods, but at this point, it's hard to get. I think I've touched on this before. Just the way agriculture is, big agriculture, and the way that they do agriculture here is just. They refuse to change. They just refuse. The only thing they want to do is get bigger and bigger tractors, and bigger machinery to harvest and to do the farming tasks. They don't really want to change the way they do things. So agriculture, in my opinion, is very archaic in some ways. Whereas a lot of this stuff you could solve by using other methods, but they choose not to use them. Neither here nor there. Um, but how can GMO be good? For instance, right now, okay, let's go back some. I think it was in the 60s. No, it may have been the 50s, but it was a long time ago. Um, the banana that you see now, the on the grocery store shelves. The main banana that you see now is like Grand Nain and I forget what other one, but right now it's going. Something is happening that happened again. That banana that you see in the store now is not the banana that was widely and commercially grown back in the day. Back in the day, the bananas suffered fusarium wilt, which is a disease, and it pretty much wiped out all the bananas. The bananas that used to be widely grown and sold in grocery stores were called Gros Michel, which is Big Mike. That means Big Mike in French. Um, and that used to be the main banana that you would see. You can still purchase Gros Michel, which I think I want to purchase some because I want to taste it. They say they taste better than the ones that are in the store now. But there are still, you can still buy it. There's still some plant specimens left. But they just don't grow it commercially anymore because the one that they grow commercially was resistant to Fusarium wilt, which is if I'm not mistaken, it's a fungus, I think. But anyway, it affects the plants and it pretty much can jump from one plant to the next. And if you know how they grow bananas, they grow them in a grove or just like they grow any other tree, even though it's not technically a tree, but that's neither here nor there. They grow them, right next to each other. And this disease can be passed from plant to plant to plant. It pretty much kills the plants. It wipes them out. So once they found a genetically resistant one, which is what they sell commercially now, they just switched to that. They said there's no way that we can stop this disease from spreading, so we'll just switch to one that's genetically disease resistant to this Fusarium wilt. Well, guess what? Now this one, some other, I think it's a different strain of a very similar disease is now attacking these bananas. And it's starting to wipe out the bananas that they're growing now. Well, they were able to find a banana that is genetically resistant to the current one. And what they did was they genetically took genes from that one and put it into the one that they're growing now. Now, keep in mind, the bananas that we eat in the store do not reproduce by seed. They don't have seeds in them. They reproduce by pups. So they had to go into a lab because there's no way. Remember my little scenario with the cucumbers where you can cross them and then save the seeds and grow the seeds out? Okay, well, these bananas don't grow by seeds, so we can't do that. So we have to take genetic plant material, inject it into another one. We do this scientifically, research in a petri dish, basically. And then we're able to get little cultures of plant material that will then grow into a banana tree. And that banana tree, which is basically a hybrid between two different ones, will grow and it will be resistant to this new current strain of this disease. Now, the potential danger in GMOs is that plant specimens can spread unpredictably. Meaning, suppose these plants are genetically superior to other plants and they can smother out, you know what I'm saying? But because it's a banana plant and it doesn't spread by seeds, it's not that big of a deal. It has to spread by a pup. So it's not like the seeds can blow, down the street and propagate themselves and then blow. You feel what I'm saying? Like, bananas don't work like that. It's pretty easy to get rid of bananas, to be honest. If you chop them down and burn the area, but just pretty much burn up all the roots and stuff, they're done. Like, it's actually pretty easy because that's how, when they have diseases on these fields, that's how they get rid of them. They cut all the trees down, they burn all the plant matter. They pretty much torch the ground. That's how they get rid of them. And get rid of the disease, get rid of the plants, get rid of everything. So in this case of GMO, there's really no potential risk. There's no risk of these plants infecting something else because they don't create seeds, they don't pollinate, you feel me? There's a way for them to actually save this strain of bananas, but they can't because people is saying, "Oh no, they're GMO," but there's no risk in this because there's no seeds. You feel what I'm saying? That's the main way that plants that are genetically modified get out here, and just like invasive plants, that's how they is mostly seeds. The seeds spread and go everywhere, and you can't control it. There's no risk of this banana, like, because and they're not growing in an area where bananas don't grow. They're growing them in areas where bananas grow. Because I mean, to be real with you, most of the world bananas won't grow because it gets cold and it kills them. If you keep killing bananas down to the ground, what are they? They're nothing but an ornamental tree. Like, they don't do anything. They don't produce. You see what I'm saying? So it's like, so I'm saying all that to say is, don't always be so concerned with. I'm not saying to consume GMOs. That's not what I'm saying. What I'm saying is, if you really don't understand how that GMO was created or what it was created for, don't always assume that it's negative all the time. Because there are cases where GMOs can actually be the answer to solving some of these problems. GMOs aren't always bad. They aren't always some negative buzzword that you should just jump out and automatically, just like people automatically gravitate towards organic. Organic, in my opinion, don't mean nothing. It don't mean nothing to me because I wasn't there when you grew it. So I don't know if it's organic or not. People lie all the time and say stuff organic. They be lying. It is what it is, you know. So, you know, you just have to be diligent in seeking out accurate information. And if you don't understand something, try to understand it before you um, just have some visceral reaction to it. Because a lot of times that's what they want you to do. They want you to have some visceral reaction to something, and you really don't even know what you're talking about, you know? And that's not a wise thing to do. So I hope the mosquitoes ain't biting. Um, so yeah, that's pretty much all I really wanted to talk about in this video. So yeah, y'all just, you know, be on the lookout. All GMOs aren't bad. All of them aren't good either. Just, you know, tread with caution. So until next time, see you guys later.